Hi, everyone. This is today's lecture on air pollution. So please make sure you have out a notebook so that you can take notes and that you've titled this section of these notes Air Pollution. First, we are going to talk about outdoor air pollution. So you can make a subheading in your notes. Outdoor air pollution includes chemicals and small particles in the air that can come from one of two places. They can come from natural sources such as sandstorms, volcanic eruptions, wildfires, like what I'm showing you in the top picture is a volcanic eruption, or they can be anthropogenic, which means they are human made. Anthro means people and genic means generate. So people generated sources such as pollution from factories and pollution from the combustion of fossil fuels, either when we drive our cars, when we burn fossil fuels for power, or a variety of other reasons. The bottom picture on the right here is actually showing you the Suncor oil refinery here in Denver and some of the pollution that it emits on a regular basis. Pollutants can also be classified as either primary or secondary pollutants. Primary pollutants are air pollutants that are released directly from a car, a power plant, or some other source. Secondary pollutants are formed when the primary pollutant reacts with either another pollutant or chemical and the air and forms something else that is also a pollutant. For example, ground level ozone forms when pollution from fossil fuel burning reacts with oxygen and sunlight in the atmosphere and forms ozone, which is considered a pollutant when it is in at the ground level. So secondary pollutants are formed from primary pollutants as they interact with the environment. Outdoor air pollutants. Some examples of outdoor air pollutants. If we're talking about primary pollutants, some examples would be sulfur dioxide, which you can write as SO2, nitrogen monoxide or nitrogen dioxide, which we just generally call NOx, NOx, because it would either have no number or it would have a 2. So we just call both of them NOx. Carbon monoxide, which is CO. Carbon dioxide, which is CO2, which we've talked about in relation to the carbon cycle already. And particulate matter, which is any particles that are smaller than 2.5 microns. Particulate matter is actually of great concern because the particles are so small that they can penetrate the cells in our lungs and enter our bloodstream. Secondary pollutants in the outdoors include ground level ozone, which we just discussed on the previous slide, and then sulfuric acid as well as nitric acid. And both of these acids are related to acid rain. So, acid rain itself is a secondary pollutant, which is caused when sulfur and nitrogen oxides are released from burning fossil fuels. And they're released into the atmosphere where they form sulfuric and nitric acid that then falls back down to earth with the rain, and the rain itself then becomes acidic, which can cause all kinds of problems for environments and wildlife. This is a diagram that sort of shows you some examples of primary pollutants and secondary pollutants and some of the sources that they come from. So we already talked about almost all of these in this primary pollutant bubbles here, except for ammonia and VOCs. And then remember that secondary pollutants form from these primary pollutants interacting in the atmosphere once they're released. And then some other secondary pollutants that can form would be ammonium, sulfur trioxide, hydrogen peroxide, and then sulfuric acid and nitric acid, which then would come back down as acid rain. Okay. Major sources of outdoor air pollution, you can probably guess, include the burning of fossil fuels, not just by industries and power plants, but also use of fossil fuels in homes, such as natural gas, driving cars. All of that is a major contributor to outdoor air pollution. Air pollution can come from point sources or non point sources. So, this is similar to what we learned about when it comes to water pollution. For air pollution, you can also have a point or non point source. So, for point sources, that's going to be any air pollution that enters from an identifiable source, like a smokestack from a factory, like what you see over here on the left. Non-point sources are going to be pollution that comes from a dispersed area, from a general region, or from something mobile like cars, where there's not just one source, it's a whole area that is contributing that pollutant. So these basically mean the same things that they did when we were talking about water pollution. We're just now talking about air pollution. So now let's talk a little bit about air pollution and health, because that's the main reason that we care about it. So, in addition to the 6 criteria pollutants, which you will be able to see in a table on your note catcher, if you did not know that there was a note catcher, you can go back to today's folder and you can open that up and you will see a table that I've put in there for all of the major pollutants so that you don't have to spend a million years writing those notes. Okay, so there are 6 major or criteria pollutants, but in addition to those, the EPA also recognizes 187 other hazardous air pollutants that can cause a variety of health effects, such as cancer, developmental defects to unborn babies, damage to nervous systems, and respiratory conditions such as asthma. Air pollutants are thought to decrease the activity of genes in our bodies that help us maintain normal immune systems. And so that's often why people who live in areas with higher rates of pollution also are at greater risk for developing asthma and allergies. So, where you live really matters. If you live in close proximity to highways and diesel exhaust from big trucks, that can definitely lead to higher rates of asthma and more respiratory issues. And as we know from what we've learned in class already and what we know simply about the world, low income and minority areas often have the most polluted air because factories and other industries are often placed where residents have less ability to fight for their rights. And those less desirable neighborhoods are also usually closer to major roads, large factories, and such as you can see in the pictures below here. It's usually our most vulnerable communities who end up living in those areas, often because they have no other choice. So, we talked a little bit about outdoor air pollution. Now we're going to talk about indoor air pollution. So, indoor air pollution may, in fact, be a greater threat to human health lately than outdoor air pollution, especially in developed or wealthy countries where we spend most of our time inside schools, offices, and homes that may contain a variety of sources of air pollution. Some examples would be cigarette smoke, VOCs from paint, furniture, dust, allergens. VOCs is actually an acronym for volatile organic compounds. And these are molecules that easily evaporate from materials such as paint, fabric, and glues. So when you paint a room or when you get a new piece of furniture and it has a smell to it, that smell is coming from those volatile organic compounds because they are the first things to evaporate from fresh paint or new fabrics and things like that. And often those compounds can be toxic to human health. Exposure to VOCs can result in asthma attacks, itchy eyes, runny nose, headaches, and then even longer term effects if you are frequently exposed to them can result in kidney damage, blood pressure, and other respiratory issues. So, indoor air pollution is not just about the things that are inside, it's about the things that make their way inside your home as well. So, radon is another outdoor pollutant that can find its way inside. And radon is a naturally occurring radioactive gas that is produced when the element uranium decays in rocks. That's missing a K, rocks with a K. And as the uranium decays, it turns into radon gas that can then seep into your home through the basement, through cracks in the foundation, and through the water in areas where we have uranium rich rocks. Colorado is actually a place where radon is a concern. So if you're interested in that, you might ask your parents if they know if your home has a radon mitigation system. If there is radon in a home and it is not taken care of, then gas over time can cause lung cancer. So you can see here like a house, right? And the rocks, the bedrock is what has the uranium in it that decays into the radon gas, and it moves up through the rock and soil and then makes its way into your home through cracks in the foundation, through the sump pump that may or may not be in your basement, and through cracks in windows, really anything that's not sealed up is a place that radon could get into your home if it's present in your area. Other examples of indoor air pollutants include smoke from burning fires inside, whether that's to cook or to heat the home. We don't all do that very often in countries like the United States, but in many developing countries, wood burning fires are still the main way that people cook their food and heat their homes. And exposure to the smoke from wood burning fires can increase risk of pneumonia, tuberculosis, lung cancer, and can also lead to low birth rates. Oh, birth weights. That should say birth weights with a W, not birth rates. You've also got those VOCs, or those volatile organic compounds that evaporate from furniture, paint, carpets, all kinds of things in the home. Mold in the home can be an issue, animal or pet hair and dandruff, carbon monoxide from cars in the garage, radon gas, which we just talked about, pollen that becomes trapped inside, and then cigarette or other smoke in your home. All of these are examples of indoor air pollutants that can harm the health of people who live there. This is just kind of showing us more places throughout the home and different types of pollutants. So, in bathrooms where it's often moist or wet, you can end up with mold and mildew. Air conditioning units can blow VOCs and other things throughout the home. Animal hair, dust, and dandruff can be an allergen in the home. Cooking devices, fuel, oil, VOCs in your laundry room or in your furniture or in your paint. VOCs are also in perfumes and candles. So if you're a candle lover like I am, they're really not always great for our health. And then things can also make it in your home from the outdoors as well. Lastly, we're going to talk about ways that we can address air pollution since it is a public health concern. One of the main ways we currently address air pollution is through regulations. So, when we regulate something, we set and enforce a limit on the amount of a pollutant that can be released by an industry or from other sources. So, an example of this would be the Clean Air Act, which the EPA, the Environmental Protection Agency, is tasked with enforcing. And they make sure that companies are not emitting more of certain pollutants than they're supposed to. And you can also implement tax credits for reducing pollution from current levels. Another regulation or policy is known as cap and trade. And this is where we set limits for total pollution that can be released by a producer or a business. So we give every business a limit, like you can only release this much CO2. And if they produce less pollution, then they technically have extra credits, like you can think of them as pollution credits. They didn't spend all of them. And so they have extra pollution credits that they can sell to other businesses who exceeded their limit. And so they would need to buy those credits. And that just sort of incentivizes companies to find ways to create less pollution so that they can sell their unused credits instead of having to spend more money to buy someone else's. We can also use technology like smokestack scrubbers. And what these are systems that are put in the smokestacks of factories. And as that smoke is and gas is being pumped out of the factory, it goes into these scrubbers that have several sets of water sprayers. So you can kind of see those here with the little arrows. And what they do is they spray a mixture of water and limestone onto the smoke, and that actually traps and pulls some of the pollutants out of that smoke and sinks them down here into the water in the bottom that they then take somewhere else to treat and remove pollutants from before they reuse it. So smokestack scrubbers can help remove a lot of pollutants from um, the waste that factories often pump out through their smokestacks. And then lastly, we can invest in and provide more mass transit options like buses and trains, in an effort to reduce the number of cars on the road. Since, excuse me, cars are a major non point source of pollution and smog in cities like Denver. They also contribute to the creation of ground level ozone, which is part of why we were not able to see the mountains hardly at all this past summer, and it always seemed hazy. Okay, so that is the end of the lecture on air pollution. Remember that we are in person tomorrow, so you need to bring your notes on air pollution to class and be ready to work in a group on an activity related to air pollution and health and decision making. Also, don't forget to fill out the attendance form that is also in this folder if you haven't done that. Have a great day, and I will see you guys tomorrow.